Yo, 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 it's Miss A, and let me go over what we're doing for today. Okay, so you're gonna watch this video. I'm gonna give you the instructions first, and then I'm gonna go over the actual lesson within the video. But first, let's go over what you need to know, so then while you're watching the video, you have everything all done, even though you're watching it now. Kind of odd. Yeah, I know. Okay, so again, I apologize, I'm not in class, but we can do this. So by the end of this class, by the end of this lesson, you will be able to describe, identify, analyze, and draw polar and non-polar molecules with 100% accuracy. Yes, I said 100% accuracy. I know you guys, you can do this. We've been working up all the steps in order to get to this, so now we're ready for the final part of it. All right, so the materials that you need, this video that you're watching, it's also linked below, all right? The lecture is just a PowerPoint in case you want to follow along or annotate that. The homework worksheets and the 2 homework worksheets. But just so you know, the homework worksheets are also in here as well, so you don't even have to, unless you want them printed, you don't have to use them. So the directions are easy. You're just going to watch this video. You're going to pause it when to answer the questions, and that's kind of it. You can answer everything either in the notebook itself, like you guys know how to do, or you can do it on a hard copy and then just upload the pictures. Remember, I'm not too picky about how you do it as long as you do it. So pick any means that you need. All right, so let's warm up first. Okay, and this part is right in the PowerPoint. And what I want you to do now, we started doing this last lesson, covalent, ionic, and metallic bonds. So all you're going to do is you're going to identify and just type it into here, whichever it is. And let's just remember for a second, quick, covalent is nonmetal to nonmetal, right? Nitrogen is nonmetal, oxygen is nonmetal, so it's covalent. Metallic is just metal, usually one metal, but sometimes it's more than one metal in there. And then ionic compound is a metal and a non-metal. If you need review on this, go back and look at the day 1 videos and lecture notes. All right, so that's warm up part 1. Again, it's in the lecture if you need to see it different. And you can go over those pretty quickly. Now, if you need to, since you guys are going to be working in class together, check with your neighbors to make sure that you're doing it right. So do a couple, then chat to make sure you guys have the right answers. All right? Warm up part 2. This part is a little bit more difficult. Now, I don't know if I should tell you this, but the answers are in the PowerPoint. First, try to do it before you look at the answers. All right, so what I want you to do now is I want you to draw the Lewis structures. The reason I want you to draw the Lewis structures is because you can't identify if something is polar or nonpolar without first knowing how they look. So these are something that you want to have done there, all right? So I do want to just say that you have to draw these. You cannot just copy and paste it, because I know I can just go on Google and put Lewis structure for CF4 and it'll pop an image for me. You have to draw it. Now you can either use the tools here that we have in the Teams notebook, or you can do it by hand and then just pop your pictures in there. And you can do 1-page pictures if you want. Remember, you can just drag and drop your pictures into the assignment. So that's fine. And there's not too many of those. Now again, a must for this part. After you do them, collaborate with your neighbors or check on the PowerPoint to make sure you're doing them right. If you're not doing it right, drop me a message in the chat so then I can help you and know that we need it. Okay? But collaboration is key. You guys are a really good class. You work well together. So use that if you're there together. All right? Okay. So that's the first part. And so that's what you're going to do first. And then you're going to start the video again, and I'll go over this right in the video with you, okay, when to do that. And then you're going to resume the video. During the video, you'll see I'll have these questions up here. So you're clearly going to stop the video, answer these questions, and then check them with the video. The video has the check in there for you. I go over each one for you. Again, you're going to watch the video again and answer these questions. They're here. And then again, we have some more. These are just your checkpoints. So I know that you're doing it as the video is going on. Okay? And then you have your homework, which again, you can print from here, or you can just, I put them in here, you can just type them again into here, type and draw. That's worksheet 1, and then worksheet 2, again, you can just put those in there. Okay? And so that's it for the instructions. So right now, before I go into the lecture part, pause this video. Yes, pause the video. answer the warm-up 1 and 2. And then as soon as you're done, you are going to unpause, and I'm going to start the actual lesson content. Okay? All right. Pause now. All right, so what are polar bonds and what are polar molecules? And so there's two types of covalent bonds. There's a covalent nonpolar and a covalent polar bond. And it is pretty simple, as it says over here. It's just nonpolar, and we're just going to call it NP, is an equal share of electrons. And then your polar bonds, which we'll just call P, is an unequal share. As simple as that. Okay, and I like to think of it as tug a rope, that there's always going to be one side that pulls it more than the other. One atom is going to pull the electron more than the other. Okay, so polar covalent bonds is this unequal sharing. Now let's think, if you have hydrogen and chlorine together, what do we know about the two of these? Which one's bigger, which one's smaller? Hydrogen is the smallest atom that we have. So if I were to draw it like, I would say hydrogen is like this, right? And then chlorine is like this. Now, if they're fighting for these electrons here, right? If they're fighting for these electrons, which do you think is going to take more of the electron?
Chlorine.
Absolutely, right? So it would be an unequal share. So this would be a polar compound, right? The chlorine is definitely going to take more. I think some of you have like animals, right? Do you ever like a dog toy when you play with your dog, right? And you have a toy, it's that unequal pull, right? They have it in their mouth and you have it in your hand. Think of it like that. Think of the dog toy as your electron. So this just says in a polar covalent bond, one atom typically has a negative charge and the other has a positive charge. And it's not really positive and negative, it's just which one has more of the electron. So if we look at it here, hydrogen and chlorine, which one do you think has more of the electron next to it? Well, this would be the chlorine, so we're going to say it's more negative. It's not that it's negative, it's just more negative because it has more of the electron. And then the hydrogen would be more positive. Does that make sense? And if you see here on the PowerPoint, this is how it's drawn in like this people here. Now, I know it's kind of small to see on the screen, and we're going to go over it later, but it's this little sign here, and you put plus or minus next to it. So this would be like this. And this would be like this. You'll see a better view later. So nonpolar is, of course, like I said, when they're equal sharing. Okay, and then think of a chlorine versus chlorine. They're exactly the same, right? So they're going to get an equal pull of the electrons. Nitrogen and nitrogen, oxygen and oxygen. They're the same size, so they're going to have the same pull. Same electronegativity, same pull. All right, and here, two dogs, they're going to have the same pull against, or the princesses and their. So this is just like a quick visual of the three different types, and these little X's represent your electrons. Not really, because we know that the electrons are orbiting around and all of this, but it's just a way that you can see it. So ionic, we know, is the total giving of electrons, so that's why it's only on the one side with one atom. If you look here. Whoops, sorry, clicked by accident. Covalent is an equal share or sharing of electron. And in this case, if you can see the second case, it is right in the middle, kind of like your Venn diagrams, sharing it perfectly. And then for polar, you have this unequal share where the electrons are more to one side of the atom. Okay? It would be nice to have this drawing, but you don't really need to. Just be able to understand it. So how do we classify these bonds? So there's actually, we just don't guess, we just don't look at the trends. There's actually a way of calculating these numbers. And what we have to do is we have to look at the electronegativity differences between them. The bigger the electronegativity difference, the more polar your bond is. Remember, polar is your unequal share. So this is the basic table that you're going to get, and this is the one that your textbook uses, so this is why I'm using it, even though you'll see on some other charts that it's 0.5, somewhere or 2, you'll see it a little bit different. So it's a nonpolar covalent bond if the electronegativity difference is between 0 and 0.4, polar if it's 0.5 to 1.9, and ionic if it's between 2 and 4. This is something that you have to have memorized, so I would write it down, highlight it. So take your time right now, write the chart down, and then we're going to practice because it doesn't really make sense until you actually see where these numbers are coming from. Okay, you ready? All right, so let's look at this. Now I want to show you here for a second. This is the chart. So if you look here, if you see the numbers, hopefully it's big enough that you can see the numbers. These numbers here are the electronegativity numbers. And remember that fluorine has the highest electronegativity. Everything else has a lower one. So it says what type of bond is hydrogen chloride, or hydrochloric acid. And I look, these numbers are the same. So if we look at hydrogen, it's 2.1. Chlorine is over here. Chlorine's over here. Here it says 3, but 3.1. Okay, a little bit different on each of the charts. So what type of bond is it? I just simply subtract them. So I have HCl, so I have 3.1 minus 2.1, which is 1.0. So what type of bond would this be? All right, so this is between 0.5 and 1.9. So it's a polar covalent bond. It's as simple as that. Okay? All right, so your turn to practice. What about nitrogen and hydrogen? What type of bond is this? It's polar covalent because its difference is 0.9, right? Okay, try the next one. What about this one? Yeah, it's nonpolar. Difference is 0, so it's nonpolar. Has a totally equal share. And this last one, ionic. This one you don't even need the electronegativity numbers, right? Because you know that you have a metal and nonmetal together. Okay, what about this one? Aluminum and chloride. So what we were just talking about was whether the whole bond, the whole molecule was polar. Now let's talk about each individual bond. Now we're talking about the actual bond. Is it a whole charge or is it just a partial charge? So this symbol, like I said, this symbol here, it means a partial charge, and it means that it's partially positive, so it's less electronegative. So it's more positive. And then, of course, the other one, if you have a negative sign, this would be more negative, more electronegative. And again, we're using this example here. There's the 2 ways that you can draw. You can draw this little symbol with the plus and the minus over here. Or if you look, you can draw an arrow. The arrow always points to the more negative side, the more negative side. And then you add this little plus to show that this is the plus side. So you can show it either way. I like the arrows because I feel like it's faster and easier. And like I said before, the chlorine is pulling harder on the electrons. And the electrons just spend more time near the chlorine. That's it. Let's practice these. So let's do a couple together, and then we'll do some apart. What type of bond and which one is more negative than this? So let's try. We have C and H. So what are the differences here? What are the electronegativity numbers? So carbon is what? 2.5, hydrogen is, okay? So in this case, what type of bond is it? Polar, so it means that there's basically an equal share, right? So I don't need any of these arrows. I don't need any of these positive and negatives here, okay? Oxygen and hydrogen, and what do we have here? So 2.1, and oxygen is 3.5. All right, my math wizards, what's the difference here? So this one's polar, right? So it's polar. So in this case, now we have to say which is more positive and which is more negative. So which is more positive and which is more negative? Okay, so if I draw the arrows, I'll draw it in red here. I'm going to draw it like this, and then this little here. It doesn't matter if the arrow is on top or the arrow is on bottom. It doesn't matter. And I'm just going to put here, like this is the bond, right? Or you can draw it like this. With the little sigma sign here. Or not sigma, there's a little sign here. Okay? Like I said, I prefer this way because it's easier, faster. And, okay, that's it. Seems pretty easy, I think. Okay, so those who are talking about bonds right now. Now let's talk about molecules. So molecules with a positive and a negative end. So 2 things have to happen here. The molecule must contain polar bonds, okay? And this is what we just did here. We look at the electronegativity numbers. And the molecule has to be asymmetrical. What's asymmetrical again? Come on, back in our math and art, I think. Oops, yeah, not the same. Why don't you take a second to write this down? All right, so here, just look at these pictures for a second. So if you look here at H and F, it's polar. Not the same on both sides. Fluorine is a little bit bigger. Water, if you look here, they're definitely not the same, right? They're not symmetrical, okay? And then this one is nonpolar. And as you can see, it's the same no matter how you slice it, how you dice it, it's exactly the same on all sides. So if we put it this way, it's the same. We cut it this way, it's the same. Okay? For the polar molecules, no matter how we cut them, I mean, even if we cut them like this, they'll be the same, but not like this. Here it's the same, here it'll be different. Because of symmetry, the polar bonds have an overall non-polar plus or minus that can cancel out. Let's look at these examples here. And to do this, we're gonna have to start drawing them to look at it. So that's why we went over the Lewis structures. So let's look at carbon dioxide first, all right? Now, how do we draw carbon dioxide? How do we draw the Lewis structure for it? So carbon has how many valence electrons? Here's the periodic table. So 4. And so how many is that total? 16. Okay, what goes in the middle? Carbon goes in the middle, and then oxygens are on the side, right? Nonpolar. A molecule is nonpolar. But now let's do the bond. So the whole molecule is nonpolar. So that's the molecule, if you give me my hand. Let's do the individual bonds here. So carbon and oxygen, which one is more electronegative? So if I was to draw in the bonds, the polarity of the bonds, it would look like this, right? Positive here and positive here. So do you guys remember like doing vectors in math or physics? And remember how these cancel out? Forces in the opposite directions? You guys don't remember any of this? Okay, so that's what this is. So the whole thing is nonpolar because these are the positive and the negative are going in opposite directions, so they cancel out. So each bond has a different unequal share, but the molecule as a whole is nonpolar. Does that make sense? Okay, let's try the next one. It's CCl4. Okay, so when you have this unequal share of electrons, it's called a dipole. You have two poles, like magnets, think of this, okay, dipole. And it's when that the two sides have opposite charges. So if you look here, you have negative, here is positive, here is positive. But all it is a dipole is when you have each side has a opposite charge. And when we went over this, it's represented by this arrow with a little plus sign. Okay, this is called a dipole. If they have less share of the electron, that the fluorine is taking more of the electron and the hydrogen is taking less of it. Okay, how do you write it? So the red ones in this little example here, the red ones are just showing individual bonds. The blue is overall. Now this first one is CO2, non-polar, so it doesn't have this overall one, right? Symmetrical, so it's non-polar. But in water, the blue shows that it's more electronegative towards oxygen. So that's why it's not symmetrical, so you have it overall. Remember that you'll have two types. And that's why I usually write it, unless I say draw, I usually write polar, non-polar, or whether going to, or I write those little up here. Like I write these little things to show. But you can just show if you have to draw, you can draw everyone whoops on the side over here, right? Or anywhere to show that this is the overall dipole moment. That this is negative and then this is positive. Here's just examples in different shapes and more practice drawing. Okay, so let's just go over a quick recap. Remember to pause the video and put this in your notes about everything we just learned today. Okay, number 1, polar bonds are your unequal share of electrons. This means that one atom is more electronegative. Perfect. Whereas your nonpolar bonds have similar electronegativities. This is your equal share of electrons. Equal share of electrons. Okay, let's talk about asymmetric molecules right now. So if you have an asymmetric molecule with polar bonds, then the whole entire molecule is polar. If you have an asymmetrical molecule with all nonpolar bonds, then there is nonpolar molecule. Then the whole entire molecule is nonpolar. Now, there's some really, really good examples I put in your team, so you want to go look at those to help you see the difference, but you'll see them clearly. Okay, and then of course, if you have something that's asymmetrical, regardless of the polarity, regardless of what the bond types are, it will always be nonpolar. All right, those are the 1, 2, 3, 4, 5, 6 main ideas from today's lesson that you should have down, and make sure that you can draw them and practice them. So now you need to, again, stop the video and complete the exit questions and your homework assignments. Like I said, again, you can do it in your notebooks or you can do it right in the digital notebook. That's it. Miss A is out. See ya.